Okay, I'm going to show you how to create a very simple date class. Okay, so you see I'm starting with this public class called driver, and then inside the driver I am adding this method called main. And it's a public static void main, takes an array of strings called args. We'll come back to that in a second. Okay, so for right now all of our classes are going to be public, and every Java program has to have one class that has a main function. Okay, so that's where the flow of control is going to start inside main. And the one thing I'm going to do now is just print out system.out.println is equivalent to a cout in C++. So this says print something to the screen. In this case, it's going to print MyDate program. Okay, so in Java, there's this idea of public and private. So the next thing I'm going to do is actually create the MyDate class, and you'll see that's also a public class. Okay, then I'm going to add some private data members here. One for the day, one for the month, and one for the year. Okay, so instead of having sections of code in a .h file that are either public or private, in Java we mark every class, every data member, and every method as either being public or private. And we'll actually meet a couple other access types in the future. Okay, so remember, the class is the cookie cutter, and the objects are the cookies. Every single date object will have its own copy of these three data members. Okay. The data members will be private, of course, or hidden from everyone except the developers of the class, but the methods will be public. So we need some methods to access this private data. So I'm going to add some getters and setters for the day, month, and year. I'm going to add a constructor, and I'll add a print method. Okay, when I refer to day or month or year inside a method of this class, it's referring to the private instance data, day, month, and year. And again, remember, every single object has its own copy of day, month, and year. Here's the constructor. Constructors are very similar to constructors in C++ in that there's no return type. The name of the constructor is the exact same name as the class. You can take parameters, and you could call methods from within the constructor. Here's a print method that will just print the month, day, and year. Okay, then we're going to go back to the driver, and we're going to start by creating this reference called bday. So it's a declaration, MyDate bday. This says create a reference to an object of type MyDate. But at this point we have not created any MyDate objects. This is only the reference. Here's where we actually create the object. So we say bday is equal to new MyDate. Again, new means go to the heap and make room for this MyDate object. And the constructor, remember, took 3 parameters for a month, day, and year. Constructor gets called automatically whenever you create an object. Okay. And then lastly, we're going to use the reference to print the date. Okay, so a couple things about this. bday is a reference to a date. It defaults to null. meaning it doesn't point to anything. And you can in Java have this null pointer exception that occurs if you try and dereference a pointer that doesn't actually point to anything. So if I had left this line out, bday is equal to new MyDate, if I just had the declaration of bday and I tried to say bday.print, that would have generated a null pointer exception because bday doesn't really point to anything. Its default value is null. Okay, when we do call print, okay, that is dereferencing the pointer or the reference, and it's saying use this object's data in those methods. So this object called bday points, or this reference points to an object that has these three data members. When we say bday.print, that means the flow of control should jump to the print method, and any reference to month, day, or year, or any methods that use those, will refer to 3, 19, and 1973. Okay, so let me kind of draw a picture here of what's happening in this code. So bday is not a date. It is just a reference. It holds the address of a date. Okay, what we're going to do is when we set bday equal to new MyDate, okay, the new MyDate says go create room for a date object, which has a day, month, and year, and return the address of that object to be stored inside bday. So bday points to this object. Okay, and then the only other interesting thing that happens here is at the end of the main function, right, we have an ending curly brace, and whenever we have an ending curly brace, any local variables go away. So bday will go away, and since the reference no longer points to the object, this object is going to be marked for garbage collection. And eventually the garbage collector will come and take that out of memory. Now if there happen to be another reference pointing to it, as long as there's at least one reference pointing to an object, it won't be garbage collected. But in this case, since there's only one reference pointing to it, it will eventually go away. Okay, let's look at the main function in a little more detail here. And I'll just go through each one of these keywords here. So we have public. That means that the main method is available to anyone to invoke. So this includes the JVM. It'll be the JVM that actually calls the main method. So it needs to be public. The word static. Okay, so things marked as static can be used without having an object created. And the typical pattern here is to create an object and then use dot notation to call methods on that object. When you use dot notation with an object, a method is called and that object's data is used inside the methods. A static piece of data does not belong to an object. Instead, it belongs to the class. So if we go back to our kind of cookie cutter and cookie example, right, where the cookie cutter is the class and the cookie is the object. Well, each cookie will know, for example, how many chocolate chips are inside of it. Okay, but the cookie cutter has some data associated with it too. So every cookie cutter has a weight, has a color, has a shape. Static data belongs to the class, and non-static data belongs to each object. And again, remember, each object gets its own copy of the non-static data. A static method can be called without an object by using the name of the class, a dot, and the name of a method to call. So you can only call static methods using this notation. So for example, the JVM at some point calls the static main method by saying driver.main. and it actually passes in some parameters there. One interesting side effect is that static methods cannot access non-static data because there might not actually be any objects with data. Okay, so this is a subtle difference that is kind of difficult for many new programmers to understand. For right now, I suggest you always having a separate driver class that contains a main function and have no other classes include a main method. Okay, next we have void. Void means main does not return anything to the caller. If the JVM is the one calling main, there are no error codes like we have with, say, a C++ program. And then we have main. This is the starting point of the program. Again, the JVM will call main for us. Next we have Stringargs. This is an array of string objects, and this allows us to send some data into the program from the command line. Okay, so I'll add some code here to retrieve data from the command line. And then I'm going to use that data like this. Okay, so if I was compiling from the command line, I would say Java C driver.java. That would compile the driver and create some .class files. It would actually, if I wanted this program to work, I'd have to also include the MyDate class. Okay. So what I tend to do is just, when I'm working from the command line, I'll say star.java. So it says compile every file in this directory that ends with the .java extension. Okay, and that will combine and compile all the Java files. Okay, now to run this program, what I would do is I would invoke the JVM. Okay, we do that with the Java command. Then we give the name of the class that has a main. So you'll find a pattern that I'm going to do a lot is I'm always going to have a class called driver whose job it is really just to contain a main. And then I do a space and I put 3 pieces of data. So each one of these pieces of data separated by a space is going to fill this array of strings called args. Okay, and what I can do then is I can refer to these pieces of data using arg0 for the first one, args1, and arg2. Okay. Now these come back as strings. If we want to convert from a string to an integer, okay, we can do that with this little helper function, integer.parseInt. We'll take a string and turn it into an actual integer. Okay. So a couple other things about Java. Ifs, whiles, for, switch, break, all of the main control structures are the same as in C++, and we won't even bother covering them. Java does add one new type of loop called a ForAll Loop. So let's imagine we had some kind of collection of card objects. Okay, so let's say this is, this might be an array of some kind. Okay, what we could do is something like this. What this says is, for all the cards in the collection called cards, we're going to iterate one time through this loop, and for each time C is going to refer to one of the cards in the array. So we say for each card C in cards. So each iteration C is going to point to a new card object. Here we could say C.print, and that will print the values out. So this would be exactly equivalent to something like this. Okay. The only difference is this is a little bit easier to write. Okay, there's fewer keystrokes, and it reads pretty nicely also. Methods are mostly the same in Java as you'd see in C++, except of course that you declare the access level, either public or private, for each and every method. Java does have method overloading. So we might have a couple functions that look like this. Okay, so two methods with the exact same name in the exact same class, but they differ in the types of parameters that they take. Okay, so the compiler can look at the function call and figure out based on the arguments which is the right version of foo to call. So if we pass in an int, it'll know to call the foo that takes an int. If we pass in a string, it'll know to call the foo that takes the string. Now in Java, all parameters are passed by value. In C++, we have the option of either pass by value or pass by reference. Pass by value means that a copy of the method argument is made and used in the method. Pass by reference says that no copy is made. Instead, a reference is made. And anything you do to the reference in the method will affect the argument passed in at the method call. So you might be surprised to hear that Java does not offer pass by reference. But you have to remember that most pieces of data that you're going to use in a Java program are going to be objects on the heap. And these objects are going to be pointed to by references. A reference, like a pointer, is really just an address of an object on the heap. So when you pass in a Java reference to a method, you're really just sending an address. And by copying and sending the address of an object to another reference inside the method, anything you do that object will be copied and reference with the copied reference that will affect the object. Okay, so let me give you an example here with our two foo methods. I might declare this integer called x and set it equal to 10. Okay. And if I were to call foo and pass in x, well, pass by value says we're going to make a copy of the argument. So it had a name num, and we're going to copy the value 10 from the caller to the function. Okay. Now anything we do to num inside the foo function will have absolutely no effect on x. So if we set num equal to 100, okay, that would change num, but it would not affect x at all. Okay, however, if we pass in an object reference, things are going to behave a little bit differently. Okay, so let's say we had a string called name. And again, this is not a real string, it's just a reference to a string. If we want a real string, we have to create one on the heap. Okay, so what we have here name is a reference. It points to an object on the heap. Okay. Now, if I were to call the foo method that takes a string, okay, remember there the argument was called str. Okay, so name is a reference. Because we have pass by value, what we're going to do is we're going to copy name, which really just holds an address, and we're going to store it inside the parameter called string. But it's just an address. So now basically what we have is we have two references pointing to the same chunk of memory. Okay. So now if inside this string function I did something to change the string, there's not really a bar method, but let's say bar did something to the string. Okay. Dereferencing str will go here and will give you access to this piece of data. Now when the flow of control jumps back to where this function was called, string will go away because that was a local variable, that was just a parameter. And now name will still point to the same chunk of data. So if it got changed at all, when the flow of control comes back, we'll see that name will refer to the updated data. So in essence, we have pass by reference with objects, but we don't call it pass by value. It's really, I'm sorry, we don't call it pass by reference. We call it pass by value, because really what we're doing is we're copying the reference from one place to another. Okay, the built-in types are not objects. And of course, they will be passed in by value. That was an example here. This was a built-in type, and it's passed by value. If you want a built-in type to be an object, there's actually a wrapper class for each one of the built-in types. Okay, so what this says is there's now a reference called x, and it's going to point to this special type of object called an integer, okay, with the full word, notice the capital I. And now that's an object that if we passed x, it would be really copying the address of the object into the function. And anything we did to the object would affect the integer called x. Okay, we saw how we could print to the console using system.out.println. Now, if we really wanted to, we could also use system.in to read from the console application. But we're not going to. Instead, we're going to use a built-in Java GUI widget called a JOption pane. And JOption panes are great for gathering data from the user. So JOption pane is like a dialog box. It pauses the execution of the program and pops up and prompts the user to enter in some text. And then the text can be used inside the program. So we'll just change this code a little bit to create this thing called a JOption pane. And the method we're interested in is called showInputDialog. Okay, so when the flow of control gets here, what's happening is we are saying, using the JOption pane, call this showInputDialog method. So notice, I did not create a new JOption pane anywhere. This is a classic example of a static method. Okay, I didn't have to create a JOption pane to use the method. The showInputDialog is a static method that belongs to the class. And what happens at this point is the flow of control will pause, and this little text box will pop up that says enter in a month. and then the user will type something in and hit enter, and that data will be, it's always returned as a string, so we still have to parse it, turn it into an int, and we do that for the month, day, and year. Okay, so I can show you what one of these looks like. Okay, so this is a J option pane. So the first one said enter in a month. That's exactly the string that we see here. So we could put in month 11. Okay, the next one says enter in a day. Put in 1. And the last one says enter in a year. Let's say 1973. So each one of these is going to return a string that will be converted into an int, and then we'll use them in the call to the constructor. And then when we print, this is a little bit hard to see, but it's 11/1/1973. So this is a really convenient way to get some data from the user. There are a couple other JOption pane options. There's a show message dialog if you just want to present some data to the user. There's a show confirm dialog if you just want to kind of ask a yes, no, okay, cancel type question. And then, like I said, it returns a string, so often we have to convert from string to an int. You can also convert in the other direction. Okay. If you have an int and you want to turn it into a string, you could do something like this. So what this does is it calls the static method. Again, in this case I did not say new integer anywhere. So this is the name of a class, a dot, and the name of the method. Okay, so that's a method that belongs to the class rather than any one particular object. And we passed in the number we wanted to convert to a string, and this method will return a string object that this reference will now point to.